is containing a number of concepts. The concepts are very important. And now you can see the PowerPoint slides. And I want everybody to join the class on time. Probably you may have some network problem or something, but try to come on time so that we can see a little bit the subject more. So the thermodynamics we started. I think the screen is visible to all of you, right? And last class we have seen two problems. So this problem, that is the heat of vaporization, and we calculated the work done and the internal energy change for the conversion of 1 mole of water into steam at 100 degrees centigrade, and we calculated, and using this problem we could appreciate the first law of thermodynamics. And the mathematical statement of first law of thermodynamics has been verified by this problem. And the next, we have seen what is a state function and what is an exact integral, and what is the speciality of the Euler reciprocity, and what is a cyclic process, and when the integration is done for a cyclic process, the differential becomes zero, the value becomes zero. If it is zero, then it is an exact differential, and all these things we have seen. And also we have calculated uh, the volume change of a function, or a volume change that is accompanied with the change of temperature and pressure for an ideal gas is not an exact function. This proof also we have seen. These are all the important concepts you have to learn. And I request all of you to work out these problems at least one more time so that you can understand the philosophy behind this problem. And also we have seen that work done is not an exact differential. For that also we have did a small problem. Now today we are going to see another important concept called enthalpy. Enthalpy of a system. This is a new state function. Actually, this is of very high importance in thermodynamics. Ajit Kumar, what is your number? Ajit Kumar, I request you to put your number. So this enthalpy of a system is another state function. It's a very important state function. Suppose at a constant pressure, and I am allowing a gas to expand from a volume VA to VB. Then the work done during this expansion is minus P VB minus VA. That is P into delta V. P into delta V is the work done. Actually, this minus sign is put here because it is an expansion. So during expansion, the system is doing a work on the surrounding. System is doing the work on the surrounding. So the final volume is bigger than the initial volume. So the sign given is minus. Work is done by the system on the surrounding. So according to the mathematical expression of a first law of thermodynamics, delta U is equal to Q plus PV, the entire work done, that is Q plus W. So we have already put the minus sign. Already we have put the minus sign here. So I can write this delta due as UB minus UV, UV minus UA. So delta U is equal to Q plus W, that W is minus P VB minus VA. So the delta U can be written as UB minus UA, which is equal to Q, look here, minus P VB minus VA. As a whole, the thing is taken out. So I can just rearrange this equation. I can just rearrange this equation. I'm just rearranging UB plus PVB. UB plus PVB minus UA plus PVA is equal to Q. So this U plus PV, this particular term, that is the combination of internal energy and the work done. It is not actually work done, it is a P into V, because work done is a P into delta V. This U plus PV is a new state function called enthalpy of a system. So enthalpy of a system, H is equal to U plus PV. So this is another state function, or I can write HB minus HA is equal to delta H, which is equal to Q. So delta H is equal to Q. Q is the heat supplied for a particular change. So in order to do this work and in order to make an internal energy change, Q amount of energy is supplied. Actually, this Q amount of energy supplied is equal to the enthalpy change. The absolute value of the enthalpy is of no meaning, and also it is not possible to directly measure the absolute enthalpy of a system. But the enthalpy change is of very high significance in thermodynamics. So I can write this HB minus HA as UB minus UA plus P into VB minus VA, which is equal to Q. So delta H is equal to UB minus UA plus P into VB minus VA. So the enthalpy change can be written as delta U plus P into delta V. This is another state function. See, the internal energy change is also a state function, and the enthalpy change is also a state function, but work done is not a state function, and also Q is not a state function. So this is a very important concept. So enthalpy is also called the heat of a process. It's a heat of a process. It is another important thing. Now listen. Suppose if I think of enthalpy of vaporization. You know what is vaporization? I am taking liquid water, and the liquid water is converted into water vapor. And for this conversion, for 1 mole of water, liquid water, to convert it into 1 mole of water vapor, what is the enthalpy change accompanied with this process? The enthalpy change accompanied with this conversion is a plus 43.93 kilojoule. So what is this plus sign? If it is a plus sign, it is endoergic process. The heat energy is supplied. You know very well, in order to convert a liquid into a gaseous substance, heat energy is supplied. At the same time, if you want to convert the gaseous water, that is water vapor, into liquid water, heat energy has to be taken out. We have to cool it down. So this conversion is accompanied with an enthalpy change of minus 43.93 kilojoule.